Hello everyone, welcome back to Maths Club. So today we have a nice Olympiad question which is a square minus b square is equal to 9. So it is our equation 1 and a times b is equal to 3. So it is our equation 2. Here we have to find the value of a plus b. So here a and b is the element of real number. So now we are going to just write it is our equation 1. So just writing 1 and it is our equation number 2. Here going to solve our equation number 1. So we have a squared minus b squared is equal to 9. So now here if we take square on both hand side, so squaring on both hand side, then we get a squared minus b squared is equal to 9. Squaring on left hand side and similarly on right hand side. Here we know that it is actually the squared, or as we know that by algebraic identity, if we have a minus b whole squared, then it will be equal to a squared plus b squared minus 2 times a times b. So using here, then we get a squared whole squared plus b squared whole squared and minus 2 times a squared times b squared, which is equal to 9 square is equal to 81. So now here exponent times exponent, we get a raised to power 4 plus b raised to the power 4 minus 2 times, here we can just write a times b whole squared is equal to 81. Now we know that from equation number 2, ab is equal to 3. So putting here value of ab, but here we know that from equation 2 that value of ab is equal to 3. Then this step will be substituting this value here. So a raised to power 4 plus b raised to the power 4 minus 2 times here ab, then we put 3 here. So 3 squared is equal to 81. Now a to the 4 power 4 plus b to the power 4 minus 2 times 3 square is actually 9. So 9 times 2 is 18, which is equal to 81. Now shifting this minus 18 here, then we get a raised to power 4 plus b raised to the power 4 is equal to 81 plus 18. Now we get value of a raised to power 4 plus b raised to power 4 is equal to 81 and 18, that we get 99. So let's say it is our equation number 3. Now as we know that by algebraic identity, if we have like a squared plus b squared whole squared, then it will be equal to here that a squared whole squared plus b squared whole squared plus 2 times a squared b squared. Now here a squared plus b squared whole squared is equal to a raised to power 4 plus b raised to the power 4 plus 2 times a times b whole squared. Now here this a squared plus b squared whole squared is equal to, as we know that a squared plus b f raised to power 4 plus b raised to power 4, from equation 3 we know that its value is 99. So putting value of a 4 plus b 4 here and then plus 2 times ab, we know that from equation 2 it is equal to 3. So 3 squared. Now 99 plus 3 squared is 9, and 9 times that 2 we get 18. So by adding this we have 99 plus 18, we get 117. So a squared plus b squared whole squared is equal to 117. Here taking square root on both hand side. So taking square root on both hand side, then we get here, then we get a squared plus b squared whole squared whole square root is equal to 117 square root. Now square can be cancelled out with square root. We get a squared plus b squared is equal to plus minus 117 And by factorization 117, we just write 9 times 13, which is equal to 117. So here 9 times 13 and a squared plus b squared is equal to, here square root of 9, we just write 3 times square root of 13. So value of a square plus b square we just find out, it is plus minus 3 times square root of 13. Let's say it is our equation number 4. So now we are again going to use algebraic identity. If we have a plus b whole squared, then it will be equal to a squared plus b squared plus 2 times a times b. So a plus b whole squared is equal to a square plus b square. Here from equation 3 we know that the value of a square plus b square is plus minus 3 times square root of 13, and plus 2 times value of ab from equation 3 we know that it is equal to 3. So now our next step is plus minus 3 times square root of 13 plus 3 times 2 is 6. So we just write here that value of a plus b whole square is equal to, that a plus b whole squared is equal to 6 plus minus 3 times square root of 13. So now here we have two values of a plus b whole squared. So a plus b whole squared is equal to 6 plus 3 times square root of 13, and other value is a plus b whole squared is equal to 6 minus 3 times square root of 13. So when we see this this value here, we have a negative value here, so we just find out the value of a plus b, which is not real. And from this question we just write that value of ab, here ab is actually a real number. So from this we get no real solution, therefore we are going to reject this condition here. So rejected this value of a plus b whole squared. Now we are going to solve a plus b whole square, 6 plus 3 times square root of 3. Now if we take square root on both hand side, then we have cancelling square with square root, a plus b is equal to, as we know that we have to find the value of a plus b, so we are going to find from this condition, this possible condition here. So square root of 6 plus 3 times square root of 13, here we just write plus minus square root of 6 plus 3 times square root of 13. So here we get positive values, and the two conditions are a plus b is plus square root 6 plus 3 times square root of 13, and other values a is a plus b, it is minus, that we get 6 plus 3 square root of 13. So now we see that here it is our positive value a plus b, but here if we see that it is our negative value, so we just write there that no real solution as well. There is also no real solution, so we are going to reject this value here. So rejected this value as well. Hence a plus b is equal to, 6 plus square root of 6 plus 3 times square root of 13. So it is our value of a plus b. Hence we have find our final answer, that value of a plus b is square root of 6 plus 3 times square root of 13. Now we are going to check our entire solution here. So it is our final solution that we have just explained step by step here. So if you have any problem, you just ask in comment box. So that's it for today. Don't forget to subscribe my channel for more interesting contents. Thanks for watching. Goodbye.